Prove that 4 power n minus 1 is divisible by 3. Of course, anything that is divisible by 3 is a multiple of 3, right? So, in order to represent this in formula form, what we're going to do is we're going to say 4 power n minus 1 is equal to 3a. A multiple of 3. So a is any real number. Any real number. A can be 1, in which case the right hand side will be 3 times 1, which is 3. A can be 2, in which case the right hand side will be 6, which is also a multiple of 3. So remember our step 1. Step 1 says we need to prove that this is correct for n equals 1. So if n equals 1, what do we have? We will have 4 power 1 minus 1 equals 3a. 4 power 1 is 4. 4 minus 1 equals 3a. And that's 3 equals 3a. In which case, of course, we know that a will be 1. Since a is an integer, we know that this holds true, right? Because it is divisible. What we got, which is, we got 3 is divisible by 3. So let's move to step 2. Step 2 is that we need to assume that the theorem is true when n equals k. If n equals k, what do we have? We have 4 power k minus 1 equals 3. Okay? So we are assuming that this is. Now we need to move to step 3. Step 3 says that after we assume that it is true for n equals k, we then need to prove, or we need to check that if it is true for n equals k plus 1. So again, as usual, anywhere you see n, you replace it with k plus 1. K plus 1 just basically says if k is any integer, k plus 1 is the next integer or real number or natural number. So we will now have that 4 power k plus 1 minus 1 equals, remember this is okay. So this is what we have. Obviously, we need to try to bring this all together. In this case, though, instead of using 3a, I want to show that it's not the same number that we'll get from 4 power k minus 1. So I'm going to use b instead. Now, remember how we did it in the first example? We need to look for a way to put this inside this other expression. So how do we do that? Of course, you have that 4 power k plus 1. If you remember your indices, you know that that is equal to 4 power 1 and 4 power k. This 4 power k minus 1 is not the same as this one. It's not the same because these two are together. So your multiplication will always work together before your subtraction. So they are not the same. But what can we do to make sure that we have what we need, the right circumstances, the right environment? I will have to create it by myself. So 4 power k, which is this, is equal to 4 power k minus 1 plus 1. What have I done? I have tried to bring in the minus 1 that I need to be able to relate k plus 1, sorry, to be able to relate the step 3 to the step 2. I brought in this minus 1. Obviously, minus 1 plus 1 is 0, so 4 power k is equal to 4 power. What I've done is I want to introduce that minus 1. So now I will remove this 4 power k that I have here and I'll replace it with this 4. So what we then have is 4 power k on and the actual minus 1 that was there was. So now that we have the 4 power k minus 1 that we now replace it with 3a. Okay? We have 4 dot 3a on minus 1 equals the. Remember, this a and b, they just go to show something that is divisible by. Now we can expand the bracket. And what we have is 12a plus 4 equals. So we have 12a plus 3 equals 3. Now, the beauty of this is that, look at it, 12 times any integer a will be divisible by 3 because 12 is divisible by 3 is divisible by 3, and obviously 3b is also divisible by 3. So after you look at everything together, you have been able to prove, yes, at the end of the day, after all is said and done, whatever we get as our answer on this end is divisible by. In fact, we can even go further. We can factorize it. We say 3 bracket 4a plus 3. 3's cancel each other. What we have is 4a plus 1 plus b. Remember that b is any integer. We don't even have a specific number for it. And if you calculate this, if a is also an integer, means whatever you do for 4a plus 1 will be an integer. After all said and done, statement